Good, everyone. Today, we're going to be talking about intermolecular forces. Let's go. So, we're talking about the London dispersion forces first. So, electrons are constantly moving in an atom, and there could be a moment, in a very small time frame, where sometimes there be more electrons on one side of the atom than the other side of the atom. So take helium for example. Helium has two electrons. Because those two electrons keep moving, there could be a point where the helium electrons are on the same side, which creates something we call a temporary dipole. And this can do with something we call induce another dipole in another atom. Now, what do I mean by that? Well, look, one side of the helium atom is partially negative, and one side is partially positive. Let's put another helium atom next to the partially positive side. Because opposites attract, and because opposites attract, the electrons might go to the side where it's partially positive, and that can create this induced dipole. So this partially positive charge induces this partially negative charge on another atom, or this partially negative charge inducing this partially positive charge in another atom. And later, we're going to talk about the polarizability of the atom, how easily an atom or a molecule can distort its electron cloud. Now, before we get into dipo-dipo, let's just review on polar, nonpolar, and a polar molecule, all of that. So, when two atoms are covalently bonded, they don't have to share the electrons equally. And the reason why they don't have to share the electrons equally is because of the electronegativity difference. So electronegativity is just how good an atom is at attracting electrons. And if the atom's better at attracting an electron than another atom, then this is what we call a polar bond. So the electronegativity difference of a polar bond has to be equal to or greater than 0.4 but less than 1.7. And something important to note is that just because the bonds in the molecule are polar does not mean that the molecule is polar. It has to be asymmetrical as well. So in this case, look at carbon dioxide. Carbon dioxide has two polar bonds, and they each have a dipole. So there's a dipole going from carbon to the oxygen on the left, and a dipole from carbon to the oxygen on the right. Now, these dipoles, they're gonna cancel each other out because the net dipole is 0. So this specific linear geometric structure makes it so that CO2 is a non-polar molecule. Now, dipole is when one end of a dipole in a molecule gets attracted to another end of a molecule that has a dipole. So, let's take HCl for example. Because hydrogen is less electronegative than Cl, this creates this dipole because the electronegativity difference is more than 0.4. And you see how Cl is partially negative, so the arrow is pointing towards Cl, and hydrogen is partially positive? Well, what if we place another HCl molecule next to it? Well, the partial negative charge from Cl will attract the partial positive charge of the other HCl atom, the hydrogen part. And this is the dipole-dipole. intermolecular force. Finally, we have hydrogen bonds. Hydrogen bonds are a very special type of intermolecular force because they're the strongest type of dipo-dipo. And the most common atoms involved in hydrogen bonding are fluorine, oxygen, and nitrogen. Now, let's take a closer look at how the hydrogen bonds form. Imagine a molecule where hydrogen is covalently bonded to a more electronegative atom. The hydrogen atom carries a partial positive charge due to electronegativity difference. And the reason why hydrogen bonds are so strong is because the electronegativity difference is huge. So hydrogen's electronegativity is 2.2 and fluorine's electronegativity is 4. So you would imagine that if they were bonded together, it would have a very strong partial negative slash partial positive charge. And let's look at an example of this. So let's take a look at water, H2O. So this molecule is polar and it has a hydrogen bond. As you can see, it's bonded to oxygen. Two hydrogens are bonded to oxygen. And what can happen is that we can take another water molecule, another H2O molecule, and we can get an oxygen to get attracted to a hydrogen in another water molecule. So imagine we have this other water molecule, and this partially negative oxygen will be attracted to this partially positive hydrogen, and that creates this hydrogen bond. And these intermolecular forces, they affect stuff like boiling point, melting point. And the stronger the intermolecular forces are, the higher the boiling point. Now, why? Well, in order for a liquid to go from a gas, you need to break the bonds between the molecules. And if the intermolecular forces are stronger, you're going to need more energy, more heat to break those bonds. Now, finally, we're going to be talking about polarizability. So, imagine that you have an atom of helium. And let's compare that to an atom of krypton. Which atom is more polarizable? Well, the thing you need to know is that the larger the electron cloud in an atom or a molecule, the easier it is to be distorted, the more polarizable it is. And because down a group, the electron cloud increases since we're adding more shells down a group, it would make sense that the polarizability of krypton would be greater than the polarizability of helium. Helium at most can have 2 electrons on one side, which is a pretty weak London dispersion force. While krypton, it has the ability to have 36 electrons on the same side, which is significantly stronger than helium. And I hope y'all enjoy the video. Merry Christmas. I hope y'all get something good from Santa, you feel what I'm saying? And have a nice day.